General Motors is signaling a major recommitment to the V8. Not just tweaks, but a ground-up redesign intended to power the next chapter of the Silverado 1500. Whether you live for torque curves or dealer lot drama, this is a watershed moment. GM's engine team appears to be building a V8 architecture designed from scratch to deliver higher efficiency, more power density, and crucially, better durability for heavy-use pickup work. That matters because full-size pickups remain the highest margin, most strategically important vehicles for Detroit's volume and image. What GM has officially said, and what's been reported, GM has announced large investments and shifts in its propulsion manufacturing footprint related to new V8 work, and several outlets have reported on next-generation V8 projects intended for forthcoming trucks. For example, reporting earlier this year documented a major GM investment tied to next-gen V8 construction at its U.S. facilities, and industry coverage has linked that cash to new small block architectures and block head upgrades. Those moves come against a complicated backdrop for GM. The automaker has publicly expanded its truck engine lineup for 2026 Silverados. Current V8s like the 5.3-liter and 6.2-liter remain in the catalog, even while regulators and investigators have scrutinized some existing V8 durability issues. In short, GM is rebuilding the V8 story while repairing and improving trust in its existing engines. So what would a ground-up V8 actually mean? When engineers say ground-up redesign, they're not usually talking about swapping a camshaft and calling it a day. A full ground-up V8 program typically includes at least three major elements. 1. New block architecture. Improved materials, revised cylinder spacing, and crankshaft bearing arrangements to support higher loads and reduce failure modes under heavy towing and repeated high-stress use. 2. Reworked breathing. Intake and exhaust that improve flow, sometimes moving to overhead cam designs or radically revised pushrod heads to raise volumetric efficiency without sacrificing low-end torque. 3. Electrification and friction reduction baked in. Modern V8 programs almost always include carefully integrated mild hybrid assist, 48-volt systems, improved thermal management, and low-friction coatings to hit fuel economy and emissions targets. Industry reporting on GM's investment mentions money going into block, cam, and intake development, which suggests GM's next V8 is being engineered from the block up rather than modified from the current Ecotec 3 family. That's exactly what you want to hear if you're looking for a real performance and durability leap. Expert view. Why block and bearing design matters more than peak horsepower. Take it from veteran engine builders and powertrain engineers. The single most common catastrophic failure mode in modern high-output truck V8s is bearing and rod failure under sustained heavy loads. Redesigning the block and crank bearing architecture is expensive, laborious, and time-consuming. But it's the most effective way to improve long-term reliability for trucks that tow a lot. That's relevant to GM because NHTSA probes and recalls tied to some 6.2-liter V8s highlighted how high-stress stovepipe failures can cascade into catastrophic breakdowns. A new block with redesigned bearing caps, improved crank geometry, and better metallurgy would directly address those failure paths. In short, the investment is likely targeting reliability first, performance second, and that order is correct for a pickup buyer. Performance expectations. Numbers to watch. GM's current big block options in Silverado today push roughly 355 horsepower 5.3 liters and 420 horsepower 6.2 in factory tune. A true ground-up small block redesign could plausibly deliver a 10 to 20% jump in power density while offering better mid-range torque and improved thermal efficiency, especially if combined with a mild hybrid assist or boosted induction strategy. Concretely, that could mean baseline V8, 380 to 420 horsepower with broader torque plateau than current 5.3 liters. Performance variant, 450 to 500 horsepower from a high-output tune with better spool and transient response. Fuel economy gains, several percentage points via reduced friction, better combustion, and electrified ancillaries. Those are realistic targets based on modern engineering improvements and GM's public investments. None are guaranteed until GM publishes official output figures. Production and timing where the engines will be built. One of the clearest public signals is money. Reporting from trusted outlets shows a substantial capital outlay to upgrade U.S. engine plants for next-generation V8 work. That investment indicates GM plans not to import or outsource this engine line. It intends domestic production capacity, which has supply chain and quality control benefits for trucks sold in North America. Estimates in reporting tied these investments to production ramp windows in the 2027 timeframe for some facilities. But GM's program timeline could put initial derivatives into late 2026 model year trucks, depending on validation schedules. Competitive context: why GM needed to act. Ram and Ford have been jockeying for V8 headlines. Ram's return of Hemi V8 options created a lot of market excitement and strong early orders, demonstrating there's still a passionate V8 market. Analysts note that when a competitor makes a bold play, it forces others to respond not only with numbers but with credibility about longevity, warranty, and support. GM's heavy investment and ground-up work look like a direct strategic response, provide modern V8 performance and efficiency while addressing durability concerns head-on. The regulatory and warranty angle. A redesigned V8 isn't just about bragging rights. It's about reducing long-term warranty exposure and regulatory risk. GM has faced scrutiny for engine failures in recent model years and recall work tied to some V8s. Building a more robust architecture reduces the risk of future large-scale repairs and potential net escalations. Expect GM to lean on improved metallurgy, stricter machining tolerances, and longer accelerated life testing to justify warranty terms and restore confidence. What this means for Silverado buyers today. If you're shopping for a Silverado in the current model year, 2 practical takeaways. 1 near term. Current 2026 Silverados will continue to offer familiar V8 options, 5.3-liter, 6.2-liter, TurboMax, etc., with well-documented specs and dealer availability. Those engines are mature and supported today. 2. Looking forward. If GM brings a ground-up V8 into late 2026 or 2027 Silverados, early adopters should expect improved mid-range torque, possibly higher horsepower, and, crucially, stronger warranty or campaign coverage to ease buyer concerns. For fleet buyers, the improved durability could be the real value proposition. Risks and unknowns. A few important caveats. New engine programs are expensive and complex. Ground-up designs often carry initial calibration bugs and teething issues, which is why ramp timing and extensive testing matter. Production timing in published investment reports pointed at 2027 scale production for some facilities, so the exact 2026 fitment and availability remain to be confirmed by GM. Until GM releases official specs, horsepower torque figures, and exact model availability are educated forecasts grounded in observed investments and engineering practice. Bottom line, why this is big news. If GM has indeed revealed a ground-up V8 architecture for future Silverados, the importance is threefold. Strategic. It signals GM is committed to winning the high-margin truck wars with an engine that's both modern and built for heavy use. Technical. A true block-up redesign addresses the weakest link in modern high-output V8s, bearings and block rigidity, and it opens the door to better breathing, hybrid assist, and higher power density. Market. Competitors' V8 moves and the market's appetite for familiar, gasoline-powered muscle make a next-gen V8 not just desirable, arguably essential, to retain buyers who equate trucks with torque.